Good morning, good afternoon, good evening to all the participants in this session. My name is Radhakrishna Singuru. I'm a DMTS senior member working for the software engineering practice under the Industrial and Engineering Services Group in Wipro Technologies. I have graduated from IIT Kanpur in computer science and engineering. I have more than 24.5 years of industrial experience in the areas of product and systems software development. My areas of interest include large scale and distributed platforms, cloud and virtualization technologies, switching and networking, blockchain, quantum computing, AI ML, edge computing, cloud computing, etc. Today, we are going to present details around data sovereignty collaboration platform for autonomous vehicle, along with my colleague Akhil. Akhil, you wanted to introduce yourself?
Yeah, sure, Radha. Thanks. I'm Akhil Gokhale. I'm also working for Wipro in its IES division. I have around 20 years of experience in software engineering. Generally, I work for the cloud technology and I'm cloud architect here. My area of interest includes giving customized solution for our customers in the public cloud area. And I have special interest in the automation, autonomous vehicle. Yeah.
Thanks, Akhil. So, a brief abstract about the topic for today's presentation. In today's digital world, data sovereignty has become a big area of concern for various countries. Due to the rapid development of cloud computing, most of the data that is collected by various applications are being processed and persisted outside the geographical control of a specific country. So governments across the globe are enacting new and stringent laws for data sovereignty. This is pushing various industries, especially the autonomous vehicle industries, to innovate more and create new business models for data sovereignty compliance. This mandates for a data collaboration platform that ensures data sovereignty and enables data-driven development of autonomous driving built on the principles of distributed architecture to solve various challenges faced by autonomous vehicle development teams. So the agenda for today's discussion, we will cover the below topics. What is data sovereignty? How is it related to autonomous vehicles? What are the various challenges in building autonomous vehicles? And we will propose an autonomous vehicle rapid collaboration platform to help solve some of these challenges. Then we will talk about key features of this collaboration platform. And we will speak about a distributed architecture which will help solve some of these challenges, how this platform can be deployed using various cloud and non-cloud options. Then we will talk about the key benefits of this platform. And next, we will touch briefly about how this platform can be extended to other industry domains, then we will conclude. So what is data sovereignty? Today, due to the rapid evolution of cloud computing, data that is collected by various applications is stored in various data centers of the cloud providers, which can be within the country of a specific or outside the country. So this is leading to a lot of challenges in terms of having control on the data that is collected. So the key for data sovereignty is the data that is collected must remain within the geographical boundaries. So the data that is collected should be subjected to the laws of the country in which it is collected. So different countries have come up with different data sovereignty compliance requirements. So data sovereignty is more around country specific requirement. So we can say that data sovereignty per se as a national home. So now this data sovereignty is applicable across industry domains, be it healthcare, be it financial, be it energy and utilities, as well as in auto industries. So in today's discussion, we are going to talk more around how it affects the auto industry and how the data that is collected is ensured that it complies to the data sovereignty requirements. But at the same time, it still helps the autonomous industry development team to innovate and be productive. In autonomous vehicles, huge sets of data is collected from real world for creating a precise model of the world. So this specific data that is collected needs to adhere to the specific data sovereignty requirements of the country where it is collected. So now we are going to talk briefly about what are autonomous vehicles, how are they classified, what are the current industry trends, what are the key challenges involved when you develop an autonomous vehicle, and how a platform can be built to handle this challenge, but at the same time enhance the innovation and the productivity of the teams working on it. So what are autonomous vehicles? So autonomous vehicles, an autonomous vehicle is a vehicle that is capable of sensing its environment and moving safely with little or no human intervention. So a vehicle that can drive on its own, a vehicle that can sense the environment and be able to drive on its own. So how is this achieved? So the autonomous vehicles, they rely on various sensors, actuators fitted on the vehicle. They have inbuilt software which runs complex algorithms, machine learning systems, and powerful processors to execute this software. So the sensors can vary from one manufacturer to another. Some use radar sensors to monitor the position of nearby vehicles. They use video cameras to detect traffic lights and to read various road signals, track other vehicles, track pedestrians. And some manufacturers use a different technology called LiDAR. So these various technologies vary in terms of cost, in terms of capability. So for example, radars, they cost less they can work better in cloudy environments or in the nights. But they can't give a detailed view of the vehicle or the pedestrians that are moving in. Whereas leaders are more costlier, but they have limited capabilities during nights, but they can give you a more specific geolocation of the specific vehicle or a specific person in terms of the size and the details. So autonomous vehicles are briefly classified into 6 different categories. The first one, where we call level 0, there is basically no autonomous involved. You typically see the general cars where they can give you a indicator saying that your door is unlocked, but nothing beyond that. So they are more like automated systems than any automation in that. So the driver has to operate this vehicle completely. Then moving on to level 1, here you have some driver assistance. So it can control, you can keep the car in cruise control. It can help the driver in parking. It can give you parking assistance. But still, the driver holds the wheel and controls the pedals. Level 2 is about partial automation. Driver is monitoring at all times. Vehicle drives, but there might be conditions where it gives the control to the driver, or the driver has to take control when they feel that it's not safe. Level 3 is about conditional automation, where the vehicle is driving itself and driver should be there to regain control, but most of the tasks the vehicle can drive to a large extent. Then you have level 4, which is very high automation. Driver is not required at all times. Vehicle drives itself, but there can be some specific cases like vehicle drives itself on a highway where there's not too much of traffic and other stuff. Then moving to level 5, which is fully automated, where it is completely driverless and the vehicle drives itself. You need to just say the starting dish and the destination where you need to go, and the vehicle takes you. So this is completely a driverless automation. So today we are at a stage where we see L3 and to some extent towards L4, and there is more to go towards a fully automated level 5 kind of automation. So what are the key benefits? Why do we need autonomous vehicles? So autonomous vehicles help in reducing the accidents. As we know, 90% of the traffic deaths are caused due to driver distraction. So autonomous vehicles can really help in reducing these accidents. Then, because of reduced accidents, you'll have lesser congestion in the traffic and smoother traffic flow, which in turn will help in reduced emissions. Since the vehicles are controlled better and a smoother traffic is happening, you can have more lane capacity. Where a road is currently has 3 lanes, the same size can accommodate for 4 or more number of lanes. Because of the continuous traffic movement, the fuel consumption will be much lesser. And People using autonomous vehicles will have reduced travel time, and obviously the transportation costs will reduce to a large extent. This will in turn help in reducing the overall travel cost as well as travel time. Also, with autonomous vehicles, you can have more efficient parking. Current parking systems where they are to plan such that there is enough space between two cars for a driver to exit. So in autonomous vehicles, the car parking can be much compact. They can drop the passengers, go to a nearby uncongested parking area and park. So all are these more efficient parking mechanisms. So overall, autonomous vehicles can bring in a lot of benefits in terms of reduced accidents, reduced congestion, reduced pollution, better fuel consumption, reduced travel, and more affordable taxes. So coming to autonomous industry trends. So as we can see on the right side, there is an expected 25.7% CAGR. Autonomous car market is projected to grow to 20 billion by 2024. And by 2030, every one car in 10 will be fully automated. And over the next 10 years, the market for self-driving cars will contribute 13.7 billion to the economy. And interestingly, if you see on the right bottom, 57% of consumers globally trust autonomous cars. And as you can see, the confidence from the developing markets and the emerging markets is even more than 57% for them to start using autonomous vehicles. So there is a lot of interest in adoption of autonomous vehicles. Okay. So yeah, so we have talked about what are autonomous vehicles, what are the current trends, what are the benefits it brings. Now let's talk about what are the key challenges when you try to build autonomous vehicles. An autonomous vehicle will involve predicting massive road networks to cover the entire roads in a country. You can imagine the effort that is involved. Then there are endless new scenarios. So autonomous vehicles should be able to handle any new scenario, the ones which are well known, the ones which are not known but able to learn from the existing scenarios. Then they are to be able to work in different weather conditions, different light conditions, different road surfaces, able to precisely identify the vehicles in the surrounding areas up to a centimeter level accuracy. So the sensor technology, the radar technology, the cameras should be accurate enough to precisely localize the surroundings. Able to predict the motion of self and surrounding objects. Since it involves human lives, the tolerance for error is zero. So they have to be accurate to the extent possible, and there's no tolerance for any errors. And they should be able to continuously learn like humans and able to take actions on the spot when unknown scenarios come in. So this is how an autonomous vehicle is built. If you see on the right side, So we need to, the autonomous test vehicles, they are to continuously collect data, significant data using the sensors, radars. And this data will be used to build a precise 3D model of the world and the ground truth generation. So this data which is collected will be annotated and fed to artificial intelligence and machine learning models to create models which can take action, to create models which can wade through different scenarios. So once these models are built, they are tested in simulating environments to test all conditions are validated. So once this is tested, then they are taken to real grounds where they are tested for the final execution. And this is a continuous loop back. Whatever is learned is again fed back to the models, and the models are rebuilt, and then again they're tested for validity and then tested on real grounds before moving ahead. So to build such vehicles, to handle such challenges, and to ensure that the data that is collected still adheres to data sovereignty compliance, we propose a collaboration platform. What is a data collaboration platform? So various auto companies, they have teams working in different locations. They take the data, be it a data scientist, be it an algorithm engineer, be it a sensor engineer. They take this data, feed it to their systems, ensure that they are working as expected, and then again feed it back to the system to build new models. And this has to happen continuously, and these teams are working in a distributed fashion spread across the globe. So a platform that can help them to collaborate, but at the same time ensure the specific country specific data sovereignty aspects are handled is a big challenge. So we propose a collaboration platform which can help handle these challenges, but at the same time ensure innovation is enhanced and productivity is not reduced. So these are some of the key features of the platform that we propose. So this platform should be able to handle data ingestion challenges. So there's huge data which is coming in. It can be real time or near real time. The sensor data that is collected from the vehicles is either sent to the nearby data center or directly sent to a central location. This data has to be processed real time. So the platform should have capability to process real time data. At the same time, there's a lot of data which has to be done offline as well. So batchline offline processing capabilities should be a key feature of this platform. Then this data that is collected has to be used by various teams spread across the globe. They should be able to catalog this data. They should be able to extract certain parts of that huge data to try out certain specific scenarios in which they are interested. They should be able to label the data. They should be able to pre-process, like remove duplicate data, validate certain contents of the data. They should be able to search whatever specific scenarios they're interested and extract those specific data, able to extract and able to view those specific contents. And all this should be able to work in a distributed manner. The data that is extracted should be stored in those relevant locations rather than being moved between locations. They should be able to have upload and download features for this data capabilities. So that's all under data collaboration. And the data that is being collected, you should be able to visualize that data. You should be able to monitor how the various components of your platform are working. You should be able to set certain alerts and messaging so that exceptional activities are handled accordingly. You should be able to see the logs, analyze them. You should have capabilities for data lineage, how the data has started, from where the data has come, how it has traveled, how it has changed, and how it stands today. So the data lineage capability is another key feature. Then the next is around data processing. Since the data is so huge, you should be able to compress it, able to process it close to the source, able to provide capabilities to process different kinds of data, because different vendors use different formats of data like RAWs, ADTF, HDF5. So these are different formats of data. So your system should be able to process different types of data. Then the key aspect around data compliance, the data that is traveling between nodes should be secured, should provide mechanisms to audit, enable lineage. User should be able to see where the data has started, how it is transformed. It should allow only access to those privileged users, so user management services. Able to process and retain the core data at the edge, but pull out the intelligence of the metadata to a central location to give an overall view about the data. Similarly, the data access part, this data platform should be extendable. It should expose certain APIs so that relevant applications can be built on top of it. It should provide for secure data transformation. In addition, a lot of libraries like your computer vision tasks, you should be able to label, you should be able to annotate them, you should be able to segment the data, specific videos and images, identify the specific parts of those images, should be able to publish and update the entire platform and the models. So these are some of the key features that we propose a platform should have. And my colleague Akhil will add more details around the platform features, as well as get into more details around the architecture and other capabilities of this platform. Akhil, over to you.
Yeah, thank you, Radha. Can we have a next slide? Thanks, Radha, for setting up a right context, and like many things are not simpler for me to explain. Yeah, so let me take you through the complete architecture of RCP platform. So let me start with how actually thing works. So what happens, autonomous vehicle, right, test driving vehicles, it's essential to capture the like vehicle data, how when they run on the roads. So a lot of testing happens, and lot of fleets of cars runs through the lanes of the city, and the people fit uh, edge computing there, and they collect lots of sensor data, lidar data, sensor data, vision data, everything. And there are two ways that we can transfer this data to the central file. One is batch and one is real time. So let's start, like, because what we are talking here about, the data is in not megabyte or gigabyte. It's more like a petabyte of data. So generally what happens, like these vehicles roam around 5-6 hours in the city, and they come to the data center, and hard disk and they remove the hard disk from there, and they put that hard disk into the machine. So once they fit that machine, they will copy the data, and now the action start. The data will be cleansed, data cataloging will happen, data labeling will happen, because out of like 2, 3, 4, 5 petabyte of data, not everything is really. Let me explain you what is the engine. This RCP engine is there. It will cleanse the data, it will catalog the data, and it will help to label the data. And in this all, it will even capture the metadata. So when I say metadata, it is data about the data. So we can give what is the source of the data, what is the city, what is the project, and all other sort of information which will help to search this data in a big data platform. So what we do, we will take this metadata out and we will make it as a searchable data in a centralized data platform. So now what happens generally, as explained earlier, this data people capturing, let's say here we are giving you one scenario where we have 3 labs. One is in USA, one is in Europe, and other is in India. So generally this data capturing and will happen in US and Europe labs, and they will stay there. So now as the data sovereignty issue, that if there is a constraint that we should not move the data from like the USA lab to Europe and USA lab to India, and that is where how we can enable all those things here. So what will happen, the team which is working in India lab, they may require to search the data, they want to do some operation. So operation can have to do this kind of computation, they need to download this data locally to their India lab. So 2 things is possible. Once, if there is a data sovereignty issue, they cannot download and do the things. Then how we can enable those kind of operation? The other things, if data is marked where it can be shared across geography, then still to download petabytes of data, it requires a lot of bandwidth, network bandwidth and time. It requires 3-4 days to 8 days of time to download such a big file locally. So how we can avoid all those things, right? So the solution is like we provide one, we propose to provide one VDI based solution where the team from the India can log in to the respective lab, because they can search the data which is collected throughout the labs in USA, Europe. They, after searching the data, they will know where this data actually resides. And based on that, they can log into that respective lab and can perform all the computational tasks. So, so this is the way, right, how this distributed architecture actually works. So this applies to even if someone wants to access their data from USA to Europe, the same principle applies. And beauty of this is that you don't have to download a huge file locally. But there are some scenario like WLL kind of like scenarios where you require this data to be processed on the local hardware. So this platforms gives you the facility to subset the data. What they can do, you can search the data. Let's say, for an example, the developer sits in India lab and he or she sees that data is in the USA lab. So now they can go back to the VDI platform, they can see that data and they can subset the data. We slice and dice the data. This platform provides those kind of utility. So, so out of, let's say, 100 GB, they can subslice it to the 1 GB or 2 GB and can download it locally to their India lab and perform their hardware operation. So it saves a lot of time and it increases actually the bandwidth, total overall productivity of the people. So yeah, and this data is completely secure because everything is based on the user credential. Data is like without having the authentication, one cannot access any data. Second thing is when we do the data cataloging and when we extract the metadata, we have the facility to mark the data, what it requires, which data can move across location or which data cannot move across location. So this way, this entire platform takes care whether to use the VDI-based solution or give the user to download the data locally. Here we can even involve the public cloud for backup if the local data rules allows it. Yeah. So next slide, please, Radha. Yeah. So deployment option. Generally, what happens? Autonomous vehicle companies likes more their local data centers. Still, though there is a lot of cloud companies, public cloud companies are there in the market, still adaptability is not very high due to data confidentiality or so many other reasons. So this option we can our platform gives three options to deploy. One, this distributed architecture you can deploy in three ways. One is on-premise, other is a hybrid cloud, and third is a cloud pass. In on-premise, what happens that whatever I explained in the last slide, we will have the three data centers, and every data center you will have those through the SDN when we can access it. The second is the hybrid cloud, like maybe in India you can have your own lab, and US you can, some part of it you can host into the let's say AWS or Azure or whatever, the public cloud. Even nowadays public cloud gives you the flexibility where you can retain your data region based. So because the data is tagged, like which portion of the data can move across region, which data cannot move across region, then so those kind of rules we can put onto the data platform. And the same thing, this even if the data resides into the public cloud, it will not move across the region. And many times this hybrid cloud options gives you a better flexibility when it comes to the AI ML kind of simulation. Many times we have seen in the industry that their local data centers or their private data center may not have that much of compute capacity. So what they can do, they can process some of the data locally and can transfer that data to the local region of the public cloud. For example, if it is an AWS, you can transfer only that kind of data. You can mask that data also while transferring. You can encrypt the data while transferring, and can perform your ALML operations, which are compute intensive. This one. And the third option comes to the cloud pass, though it is on the experimental basis, where in this case, what happens, this complete RCP platform is hosted on a public cloud. And because everything is exposed via the REST API, people can utilize its all the features to the REST API. So that's the last option of the cloud pass. But we have seen that more adoption is there for on-premise, and people are slowly moving towards to the hybrid cloud offering. Yeah, next slide, please, Radha. Yeah, so now the question is how this RCP platform addresses data sovereignty problems, what we told earlier into this session. The first thing is, because we are setting this data are marked, what data can move across location, what cannot, or can, so that tagging helps to stop the data movement across the region. So this platform supports that. Secondly, because we are leveraging, if someone wants to go to a hybrid installation, so public cloud nowadays support this, and we can configure the platform in a way in a public cloud what data can be replicated across region and what should stay inside the region. And the third is the searching, data searching. As I explained earlier, every data, irrespective of the lab it is getting collected, this RCP platform collects the metadata and store it into a central location. Because we are putting every metadata there, so there is no issue of the data's homogeneity, because not actual data is getting transferred centrally, rather it's a metadata is going there, which helps to search data across the lab. The fourth thing would be the VDI-based solution. So what happens, like as I explained earlier, the person from the India lab, he can log into the VDI, which is hosted into let's say the USA lab, and from there he or she can perform all the operation. So technically, data never moves out of US lab. It's only view, but for all practical reason, data still stays inside that particular region. And because this platform is tightly integrated with all the security like authentication, so it's highly secured, and you can enable encryption as well. And last thing is the data lineage, which is really required for the auditing purpose. In case of any issues or something like that, or due to the government compliance, it's required that you should have the data lineage and auditing to be enabled on entire data journey, right from the data collected at the car sensor to the process data, which is fed back to the autonomous, like while you create the model, and that model comes back to your autonomous car. So complete data lineage system, complete data lineage pipeline is enabled for this platform, and it helps the auditing. It is also integrated with lots of CloudWatch kind of alerting and monitoring system. Yeah. Next slide, please, Rana. Yeah, so it's as explained earlier, benefits of RCP platform includes lower cost infrastructure. The total footprint of this solution is very small. It is a completely modular approach we built. We propose to build for this platform. So if you see the total print is total footprint is not more than I think 100 MB. So which is very small, but it handles, because it tried to use the existing infrastructure, and it is created on top of that the infrastructure layer and all the REST API. It encapsulates the underlying libraries which is already available in your private cloud or maybe in public cloud. The second thing would be the better utilization of bandwidth, because we don't have to download all those petabytes of data locally. Rather, we can slice and dice those files and can download only small portion of it. It saves a lot of network bandwidth, and that's why the overall development time also get reduced and productivity increases, and we can use the better utilization of the network bandwidth. The third point would be the low cost of ownership. This is a completely microservices architecture based the platform. Each component is isolated, and each is because it's a microservices based architecture. The total cost of ownership is really less, and it is an extensible. You can plug and play with all those components. The third is the collaborative work. As explained, right, this is a data platform which enables like various people can work, like development to the tester to the data scientist, and because it's a REST based, and it can integrate with your the existing system, be it AI/ML libraries, or maybe it's a testing framework, or maybe it's a dev framework. Because of the REST nature of this platform, all the 3 people or 4 people, like a dev, test, and data scientist, can utilize this platform, which is spread across the global labs. Deployment on the deployment side, it's very flexible. you can deploy it completely in your own data center without going into the public, or you can go into the hybrid way as explained earlier. So few features, if someone wants to utilize from the public cloud, yes, they can use it. And last is the data compliance, right? So because data lineage is enabled, and it will tell you, right, and it will ensure that yes, which data is going at which stage, sorry, in which location. And because you can restrict the even data movement, the complete data platform is compliance to the local laws. And it addresses like mostly all the data sovereignty issues. Yeah, next slide, please, Radha. Yeah, coming to the extensibility portion, this data platform is not tightly integrated with the AV, autonomous vehicle. So now after this explanation, right, you might have like one can conceptualize. It is more a data platform which gives the flexibility to expand its horizon to any other industry, be it oil, or be it in the smart grid, like in utility, or even one can think about in the pharma industry, or in this example, let's say in the oil drill, when the oil drilling happens, lot of here also like gigabytes of data is generated with the oil rigs, and all this data for upstream and downstream, lot of calculation happens, and that is where AL, ML, and all those things are required. And we have seen that because this data is getting generated at the remote stations across the world, and actually data processing happens across the labs. So RCP platform gives a right fit here, even in the oil drill area. Similarly, in the smart grids also emits lots of data across the grid. And these data platforms and countries all over the world are like very, very specific to the data sovereignty for smart grid. And nowadays, it is even more important to keep data locally into your own region. And that is where RCP platforms use that flexibility to retain that data into the same region, and plus enable developer across the world to use that data and create some business value out of it. Yeah, next slide, please. Yeah, so you want to take it, Radha, this?
Yeah, sure. Okay, so thanks, Akhil. So basically, we wanted to conclude. So data sovereignty, as we discussed, is a big area of concern in the age of cloud computing, with global development centers which are processing and persisting data. So countries are concerned that the data that is collected in their geographical boundaries are not going out and going out of their control. So the need for a collaboration platform that can address these concerns but still enabled to perform business as usual is very essential. So the platform that we proposed with its distributed and scalable architecture addresses the data sovereignty concerns by ensuring the data is processed at the source, but at the same time enable users spread across the geography to collaborate. And also the platform is extensible and can be extended to other industry domains as well. With this, we wanted to conclude our session. Thank you, and I hope we were able to convey some useful and relevant information to all of you. If you wanted to further reach out to us, you can reach out to radhakrishna.singuru@wipro.com. That's my email. or akil.gokile@wipro.com. That's Akil's email. Thank you and have
Yeah,
a
thank
wonderful
you. Yeah.